So here we go. Today we're going to learn a little bit about convection currents and how they occur in the mantle. And we're going to do this through an investigation. I like to start with a little background, and just as a reminder that the Earth's surface, that crust, is broken into lots of different slabs of earth on the lithosphere, and we call those tectonic plates. And you'll notice here we've got just all the different plates that they've labeled around our earth, but they don't just sit still. In fact, if we look here, they move. Sometimes they go and they crash into each other. Sometimes they spread apart. Sometimes they slide past each other. And so our investigation today is to look at what scientists believe is a driving force behind this movement. Okay? So what we're going to look at now this is our layers of the earth. We know we start here in the middle. We've got that inner core. Here's our outer core, our mantle, and then we have our crust. But what we're really going to look for here is something that occurs in the mantle. Remember from our quiz what we said happened to the mantle? It's the convection currents. This is a common kind of a picture we see when we're looking at like a slice of the earth from the different layers. We've got here are our convection currents. They're being heated up. Oh, see, that was fun. Over in here, and as that heat, it's going to rise until it gets cool. What did we use in our classrooms to model this? What did you say, that there's lava lamps that do the same thing? You are right. Nice job. Well, we're going to show you another model, again, because we can't really look inside the earth and look in the mantle yet. And so let's go to the next slide. Now, before I play this is an image of our setup. And so here's, if I'm going to read the introduction that's on your paper that you should have in front of you. It says, convection currents occur when temperature differences cause fluid material to move. Remember, fluids are liquids and gases. It says the heat in Earth's mantle powers convection currents that affect the tectonic plates of the Earth. Because material is close to Earth's surface is cool and heavy, it sinks. When the sinking material gets close to the Earth's mantle, the high temperature is heated up again. This hot material is pushed back up to the surface because heat rises. This type of sinking and rising repeats, creating convection currents. So what we're going to do is, as we watch this video, I want you to draw and sketch the process that is occurring in this model. Now, in our model, we can see here down below, this is going to be where our mantle, the model of our mantle is right here. So this is the heat source. Do you remember what the heat source is in the earth? You said this is the inner core? Yes, because that's what's right directly above the mantle, or below, depending on which way you're looking, is below. Okay, and this up here, this pie pan, this is representing our tectonic plate. And I'm going to see if I can change the color real quick because the black doesn't put, it's kind of hard to read. Ah, look at that. So here's our tectonic plate. So go ahead. You need to, and I want you to draw this, and in a little bit we're going to try to look at the convection currents. This fluid here, we've got some glitter inside of it, so hopefully we'll see it moving in just a bit. All right, what I hope you can see here is the heat from that inner core is starting to lift up. See if I can draw on here. So going up. And then start to go down. Hey, I made a mistake. Did anybody catch it? That's not the inner core. What is right there? Oh yeah, it's the outer core. See, even teachers make mistakes. Kudos if you got it. The tough thing is we can't see inside the earth to see these convection currents. And so we try different models. So we'll look back at that pan that's on the burner in just a second. But we also have models such as this, and you can see it's just trying to show you kind of what the different versions of how those convection currents are moving and how the tectonic plates can move because of it. And this is showing just this middle view, top view, and then it's also going to maybe show, it could have showed the other view, but you can pause it to see this model and how it shows those convection currents are moving the tectonic plates. All right, back to this again. We're going to see a couple more of these. Just as a reminder, we have this is our heat source back down here. We've got our heat source. In this case, we have like a little burner. We've got this liquid here. Here's our fluid. Maybe I want to change this, there's our fluid that's going to be able to, the heat here is going to cause that to rise. When it gets to the surface, it's going to cool down, which will cause it to flow and go like this. So I want you to see those convection currents when I hit play again. We've got our tectonic plate up here at the top. All right, I wonder if I can erase. I'm going to pause this for a second. All right, so here it's got a little faster now, but you can start to see the glitter. As it gets hotter, it's going to rise to the top, and then it will slowly sink. I can see a lot of them going down. See them going down there. So we can go to the next one, another just a model. While I'm playing this one, I want to remind you of question 1. It says, draw and sketch the process occurring in the model. Make sure to include colors, labels, and arrows in your drawing. The arrows should show the direction of how these molecules inside the fluid, we've got colored water here, how are they moving up and when do they move down? And so then you can also answer question 2, where it says, what is driving the convection currents in this model? Hint, 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 has something to do with this little thing right there. Describe your drawing on the lines below and describe what happened as the water heated up. So I'm going to go ahead and hit play. How about this play? All right, look at those right there. Look how fast those convection currents are going. It's not that slow, what we'd see in my lava lamp, but you're seeing these go like, woo, 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 woo. It's like that. And it even makes that sound. Now, scientists believe that the driving force of plate tectonics are the convection currents in the mantle. And when it's talking about the driving force of the plate tectonics, we're talking about up here, what's causing this movement. And you can see that there's some spreading going on. They're going apart down below the earth. So they're spreading apart right here. But notice that it's sinking right here. We'll have it come back up. And as this one goes here, right, we saw this in our model. Now, I'm going to go ahead and do the erasing while I'm talking here. Think about, this is going for question 3. It says, what is driving the convection currents in the Earth's interior? Okay. I'm going to give you a hint. It has something to do with this heat source right there. What do we call that? That's what you're going to be answering on question 3. 4 says, in convection currents of magma, the cooler, denser liquid does this. So which one of those choices, as it gets cooled down, does it rise to the top, sink to the bottom, stay where it is, or does it stay on the top? Watch that. This is a really good little diagram. All right, so then your last question, the conclusion says, using your observations from the model, explain what moves Earth's tectonic plates. And it says, use the following terms in your explanation. You want to use the terms convection currents, You want to use the term density. Remember about what happens to things that are more dense. Tectonic plate. In our model, we use that tin pan, but we could have also included wooden blocks instead at the top. It says, where's the mantle, the core, what happens with the heat, rise and fall. So you do need to include quite a few words, so we're going to spend quite a bit of time on that. I liked this picture because it looks at a model and then shows a picture of what they believe is actually happening inside the earth. And I've got another little demo here to kind of show you what's going on inside the earth and how our tectonic plates could be moving because of the earth's surface, because of the convection currents below the mantle. Okay, there's that picture again. Okay, I'm going to finish it right here. You can pause it as you use this model to explain how the earth moves, the tectonic plates from deep inside with the convection currents.